All right, hello and welcome to this month's Power Hour, where we're going to be focusing strictly on air door actuators, the calibrations, some of the theory behind them, how they work, also some of the reasons why they fail as well. Got Patrick here with me on deck. He's going to be doing some really good, informational pieces on, again, the theory, how they work, what to look for when you're recalibrating these things, or even just diagnosing or working on them. And in the background, I've got a bunch of different little things I've got going on. Patrick's going to throw it back and forth to me a few times here so we can actually show you some things live on camera that might actually help you when it comes to either diagnosing or recalibrating or even just verifying what you're working on. So with that, we got a lot to get into in a very short amount of time. So Patrick's going to head over to the bench. That way we can get into the content piece, and I'll be in the background again, getting everything ready to make sure we can switch back and forth and show you some things live on camera. So again, welcome to the Power Hour. Thank you for being here, and we'll get into it.
Thank you again, Corey, for that introduction. I appreciate it. Welcome to the S&P Power Hour this month. Again, my name is Patrick, and I'll be helping facilitate this month's Power Hour alongside Corey. So here in Texas, we take our AC very seriously. People begin to lose their ever-loving minds, and the world begins to rotate slower if and when we don't have access to or find that there are issues with our car AC. I say this to set the tone for today's program on air door actuators and the importance of recalibrating them. These actuators are small and somewhat innocuous pieces of the HVAC system, but they're critical in bringing the entire system together to provide the cabin comfort that both the driver and passengers need. We'll be reviewing what they are, how they function in concert with the vehicle's climate control module, how and why they need to be recalibrated, and provide some useful tips along the way. All right, let's get into it. Here we see that not all air door actuators are created equal. There are simple 2-wire actuators that are ideal for simple open and close applications. There are 3-wire actuators that add a position feedback to the control module that increases the precision with which the actuator operates. And then there are 4 and 5-wire actuators that provide even more precise motor control. Later on in the presentation, we'll go over these actuator designs a little bit more, along with what to look for during calibration. With that said, I do want to point out a couple of additional things in this slide. All air door actuators, if being replaced or worked on, should be recalibrated after installation. Usually it takes some effort and energy to get to the actuators. It only makes sense to recalibrate all actuators, whether it's done manually in the case of 2-wire motors, or electronically with 3 to 5-wire actuators, to ensure that the job is done completely and that there are no repeat failures in the near future. Another thing to keep in mind, and we'll be discussing this more in depth later, is that not all the air door actuators are created equal or used for the same applications. 2-wire actuators are simplistic in design and have physical stops for opening and closing. 3-wire actuators offer a little more precision and control, while 4 and 5-wire actuators allow for much more precision and complexity, like we mentioned before. The actuator body packaging may look the same, but what's under the plastic body may be very different from what you need in the HVAC case that you're working on. Which brings me to the next slide. Here's an example of a 2008 Ford Fusion that uses 2 actuators for completely different applications in the same case. Do you see the potential issue? On the left is a 2-wire door or air door actuator used for opening and closing the fresh air recirc door, a simple application that calls for a gearing system to start and stop at a predetermined physical spot. On the right is a 5-wire temperature blend door actuator that can precisely determine gear positioning to allow for specific temperature inputs from the climate control module. What is the potential issue when working with these? From the outside, they look completely identical, but on the inside, they serve 2 completely different functions within the system. These parts are not interchangeable and will produce trouble codes if incorrectly installed. It's always a good idea to go straight to the source, the manufacturer's schematic or wiring diagram, just to make sure you know, number 1, that you have the correct actuator, and number 2, that you know what you're looking at when diagnosing and recalibrating an air door actuator. Okay, so before I get into the wiring diagrams, let's go ahead and turn it over to Corey. He's got a few things that he'd like to showcase on these actuators that'll help us a little bit later on in the Power Hour.
Yeah, and thanks, Patrick. I think that's a really good thing to bring up. And we have a almost scenario here, but it's so close that it's a great example of how we can get thrown off very quickly. So, if we look at the two actuators here, we can see they are almost identical. We have the same ears and tabs for our bolts. A little bit of a different design on the front here, but overall we do have essentially a very similar air door actuator here. But when we look, we can see that one is a 2-pin. We have one on the left and one on the right. But if we look at the other unit, we have a 5-pin actuator. And so even though these may look similar, there can be differences. Now I went ahead and got our tabs broken off here just so I can show you when we do look inside of these actuators, there are going to be differences depending on the wire count. So we may see the gear pop off here, but on our 2-wire, what we're going to see are our gears and our simple circuit board and our motor. Now that's our 2-wire. Again, we're going to go left or right. It's open or closed. So that's our 2-wire, and we're going to, basically have very little feedback or information going back to the system. It just does what it's commanded to do, one way or the other. Meanwhile, if we look at our 5-pin, got a big difference here. So instead of just the gears, the motor, and a small circuit board, we still have our motor. We have a completely different gear set along with a contact for the circuit board. And then we have our circuit board that's going to be relaying a lot more information to the control module. So again, this is just a good example of they look the same, they almost look identical, but in reality, we do have a difference in pins and information that we can gather from this air door actuator. So, again, it's one of those things where if you're pulling one out, it's the correct pin mount. We want to make sure we match it up to the one that you pull out, because it is very possible, depending on how you look it up in cataloging, that a 2-pin may be sent to you, or a 5-pin, or in some cases a 3-pin for the same vehicle, and it turns out you actually needed this one over this one, or vice versa. So again, it's good to know that there is a difference inside of these, and those pins are there for a reason. So with that, Patrick, I'll let you get back to it, but you had that on the screen. I just wanted to break one up here for them and show them what it would look like on the inside on that 2-pin versus that 5-pin.
Thank you, Court, for showing us those actuators, for pulling them apart, helping us understand what they look like on the inside. Now the question is, do we need to pull apart these actuators to understand how and when they're used? Absolutely not. So here we have some wiring diagrams. I've pulled up a wiring diagram for the previous vehicle to show the 2-wire and 5-wire actuator on the same screen. Here we can see a 2-wire recirc door actuator on the bottom and a 5-wire mode door actuator on the top that could be used for a temperature blend door or a mode door. The air doors for this car are connected to and being managed by the HVAC EMTC system, the HVAC control unit. Knowing the physical position of the actuator in the case and understanding the actuator design is made relatively easy when pulling the manufacturer's wiring specs. A little later on in the presentation, I'll pass the mic over to Corey to dive into some diagnostics and recalibration tips. But I just wanted to point out the utility of these diagrams. Now let's go ahead and take a closer look into these actuators. After taking the back off a 2-wire actuator, we can see several things. There's a small DC motor driving the actuator that's connected to a PCB, a printed circuit board. The PCB has multiple pin input locations where it can receive power and information for different commands. These commands will drive the gears. You can also see the stopping points on either side of the actuator case that create a physical stop to limit how far the actuator can travel. You probably also noticed that these gears are all plastic. This doesn't mean that they'll fail within a year or two of being in use, but plastic ages and can become weak, especially given certain environmental conditions. So keep this in mind when diagnosing and replacing air door actuators. For actuators with 4 or more wires, we first notice, in the case of this 2008 Ford Fusion, that this 5-wire actuator is identical to the 2-wire actuator. They're very easy to confuse. Please make sure that you're using the manufacturer's schematic to confirm both the position and the correct type of actuator for the job. 4 and 5-wire actuators, just like the 2-wire, have a power and ground that provide bidirectional movement by reversing the polarity. They also have a ground wire, which the manufacturer may also call a VREF wire. Unlike the 2-wire actuator, the 4 and 5 wire models have the ability to move with increasing precision and complexity through specific voltage inputs and signal feedback to the climate control module. Though we don't have a slide for a 3-wire actuator, and just so that you have a point of reference, it has a ground and power wire for bidirectional motor movement, along with a 3rd wire that receives a fluctuating voltage signal to control positional alignment. This voltage fluctuation should not be confused with the higher precision signal feedback that 4 and 5 wire actuators have. Here we can see the specific breakdown of the pin position on the PCB and the function of each wire. On the top, we have the clockwise power wire, followed by the counterclockwise power wire. While one power wire is energized, the other acts as the ground. The voltage polarity determines the direction that the motor rotates. Next is the VREF, or ground wire. The position feedback wire is used to figure out and communicate the exact position of the door back to the climate control module. It provides very precise position control through a variable voltage signal. As an example, we can use the temperature blend doors need to use very fine adjustments in door angle to provide the correct blending of warm and cold air to achieve the correct cabin temperature based on the inputs from the climate control module. If we take it a step further, we can look at actuators with potentiometers. A potentiometer is just a voltage divider. We can use the old volume knob on a stereo as an example. As you turn the knob to lower the volume, a wiper contacts a resistive strip on the PCB that decreases the volume, basically dividing the voltage. This is how we can change the volume on our vintage stereo, and I'm definitely dating myself now. We can also dim lights in the TV room, use game controllers, and control many other things by using a potentiometer. Coming back to the automotive world, if the 5-wire actuator has a potentiometer, and many will, the voltage signal will change based on the potentiometer's resistance to the rotation of the motor. Let's continue using the temperature blend door as an example. If the driver gets into the car on a hot Texas summer afternoon and wants to cool down the interior from 120 degrees to 72, it won't be done in an instant. It takes time. Once the command is given to the actuator, a specific voltage is sent to move the door motor. As the cabin temperature changes, getting cooler over time, and the climate control module is receiving this live data from the cabin temperature sensor, the potentiometer continues to make those fine adjustments based on the original climate input of 72 degrees. So just like those manual potentiometers that we can physically twist with our fingers to adjust motor speeds, the potentiometer in the temp blend door actuator is being managed by multiple inputs from the climate control module. Again, coming back to the look and feel of these actuators, some look identical, so it's very important to be mindful when ordering these actuators to verify the pin count to avoid comebacks at the shop. Pull up the wiring schematics from the manufacturer and confirm that you're getting the right actuator for the job. There's nothing worse than ordering an actuator in anticipation of removing the vehicle dash, and after receiving the actuator and removing the dash, finding out that the actuator was not what you needed. We all know how labor-intensive it can be to potentially pull just a single actuator. When you find yourself in this position, and the vehicle is an older vehicle, confirm the actuator first, and also consider replacing the other air door actuators in the vehicle. With age, plastic gears can begin to weaken. Air door actuator damper pads can become crushed. Actuator motor positioning can become an issue, amongst other possible problems. The actuators are not a high-ticket item, and the labor for replacing the next failed actuator would not need to be considered by the customer if they're all replaced together. Obviously, this won't be necessary for all cases, but for those older vehicles that may warrant such service, keep in mind the savings value for the customer and take advantage of that exposed dash.
Yeah, and Patrick, I'm sorry to interrupt you, bud, but I'm going to squeeze in here just for a second because I had this set up while you were talking because I knew this slide was going to be coming up. Now, that is a vehicle that we had here in the shop. We were doing some testing on, and you can see there's a lot of work involved. There's a lot of parts laying all over the place, bolts, screws, and pieces, right? So obviously we have an older, HVAC case here, But the theory is the same, and what we want to bring up in this point is, Patrick's been talking about, making sure we have the right blend doors, the right mode doors, those kind of things. But there's another thing we need to consider when we think about the case. If we've gone through all that work, like you just saw on that F250, we've torn everything apart, it's always a good idea to check the integrity of the case. The reason I say that is this. We have our, obviously our heater core that will be sitting here. We have our evaporator core. And of course, if we want heat, we can move our blend door, pass it across our heater core. If we want air, we can pass it across our evaporator core. However, over time, especially if these have been pulled in and out, as maybe it's been replaced, something like that, any damage, and you can see we have some here on this particular one, any damage to the seals or the sealing properties of both the evaporator core, the heater core, and even the blend doors, any sealing, degradation or something like that is going to cause us not to get the climates that we're asking for. So whether it's, heat or AC, when the driver commands a specific temperature, if we have leakage of air, it's going to be really hard for that to get to that temperature the way that the customer is looking for. So again, this is just a little side note, another quick little tech tip. If you have, again, if you're doing one, I get it. You're probably going to replace that one. But if you do have a vehicle in your shop that's torn down completely like the F250 we just showed you, this is something to always check. Double check the integrity of the sealing of the case. That way when you get those blend doors or air doors or whichever door you're replacing back in, we know that the air is going to go where it's supposed to go without any of that slippage. So Patrick, I'll let you have it back, and apologize for the interruption, but I definitely wanted to go over this because this is a very common issue when it comes to comebacks from air slippage, and we think we've done the job completely, and we did, but it turns out we have a sealing issue in the case. Just something to keep in mind when we have it torn completely apart. So thanks again, and Patrick, I'll send it back to you.
All right, here we have an example of a 2004 GMC Yukon. The temp blend or air mix door actuator is, of course, a 5-wire bidirectional electric motor that has a feedback potentiometer. The control circuit uses either a 0, 2.5, or a 5-volt signal to command the actuator movement. When the actuator is at rest, the control circuit value is 2.5 volts. A 0 or 5-volt control signal commands the actuator movement in opposite directions. When the actuator shaft rotates, the potentiometer's adjustable contact changes the door position signal between 0 and 5 volts. Another really important detail to take note of is the fact that in this example, the HVAC control modules uses a range of 0 to 255 counts to index the actuator position. The door position signal voltage is converted or translated into a 0 to 255 count range. When the module sets a commanded or targeted value, the control signal is changed to either 0 or 5 volts, depending upon the direction that the actuator needs to rotate to reach the commanded value. As the actuator shaft rotates, the changing position signal is sent to the module. Once the position signal and the commanded value are the same, the module changes the control signal to 2.5 volts, or at rest. In the example of this 2016 Chevy Equinox, we have what appear to be the same 5-wire bidirectional electric actuators that incorporate a feedback potentiometer. We must be very aware of not only the number of pin or wires coming off the actuator, but also the count range for the motor movement. It is not a one-size-fits-all situation. Using this Equinox as an example, we note that when the actuator shaft rotates, the potentiometer's sliding contact changes the door position signal between 0 and 5 volts, just like in the Yukon. The HVAC control module again converts the voltage signal to counts. So the signal voltage and counts are basically aligned to one another and could maybe be thought of as being on a sliding scale. With the Yukon from the GMC family, the count range was from 0 to 255. However, the total range of the counts for the Equinox, also from the GMC family, is 0 to 1024, with an operating range between 20 and 1000. Understanding the count range is critical for choosing and installing the correct actuator. Also, Keep in mind that the actual operating range of an actuator is determined during calibration. It's during calibration that the actuator is moved through its full range of travel, and the control module stores the min and max values for the range. Based on this range of movement, input during calibration, the module can set commanded or targeted values for the actuators. A quick glance at this wiring diagram and we can see definitively that we are indeed looking at a 5-wire actuator similar to the Ford example from earlier, with 2 dedicated wires for rotation, clockwise and counterclockwise, and then a ground wire, a 5-volt supply wire, and a position feedback wire to tie the potentiometer into the system for fine positional adjustments and precise feedback to the control module. Okay, this next slide just shows a close-up of the air temp actuator's connection points to the control module. Here we see the 12-volt and ground wires from the battery that control the actuator movement, and then the 3 wires at the potentiometer, which are the 5-volt supply, position signal or feedback, and the ground or VREF wire. Using schematics to confirm the type of actuator that you're working on is important, but how do we confirm functionality and if the actuator is working as it should? Well, there are multiple ways of doing this, some more effective than others. Here we connected our Labscope to a temperature blend door actuator. What is being done and looked at here can be a bit complicated, so let's break it down the best we can. Towards the bottom of the screen is a green trace and a gold trace. These connections are made at the 2 motor circuits of the actuator. Again, the motor can have power and ground applied to these wires to turn it clockwise or counterclockwise based on the applied polarity. At the top of the slide, we can see the 5-volt supply to the potentiometer in red, and the blue feedback signal to the module directly underneath the 5-volt supply. When the green trace motor wire is sent power and the gold trace motor wire is sent to ground, the motor turns one direction. This can be seen by watching the blue trace move downward in response to the motor command and movement. When power is sent to the gold trace motor wire and ground is sent to the green trace motor wire, the motor rotates in the opposite direction. Consequently, the blue trace feedback voltage increases and goes up. Having said this, and used the diagnostic example, many technicians simply don't have access to a Labscope or may not be comfortable with using one for diagnosing an air door actuator. What do we do if this is the case? Typically, a scan tool is more than capable of giving a technician enough valuable data for diagnosing an actuator problem. On the screen is data for a 2025 Toyota RAV4. And I've selected the control unit screen, air conditioner, and then live data to get to this particular screen view. Once the live data was shown, I specifically put a check mark by only the target and actual pulses for the driver side and passenger side servo motors, or air door actuators. The graph shows how everything matched properly to begin with, and then as I adjusted the driver side temperature, the actual target followed the desired target. Desired is nearly immediate, and actual takes a little time to get there since a gear is actively moving the door. This is good information for a technician to understand that desired doesn't match actual for a little bit during any time that the door position is moving. Another tech tip that I'm sure most of you all know about is that initializing and recalibrating air door actuators can be as easy as connecting your scan tool software to the vehicle and going through the steps on your screen. Just make sure that the actuator is fully installed and seated on the case before initializing the recalibration process. To get a live view of what using the scan tool looks like to recalibrate air door actuators, I'm going to pass the mic over to Corey at the bench to give us a closer look at this process.
All right, well, thank you, Patrick. And yeah, I mean, we have a lot of conversations around Labscopes, picoscopes, utilizing them, hooking them up correctly, and being able to interpret data from the picoscope or whatever Labscope you may have available to you. But what we know for sure is not every shop has Labscopes, and not every shop has a Labscope, user or someone who's very familiar with Labscopes and, getting the data that they need from it. So in those cases, we always try to look back at the scan tools that we have available to us. Can we get some of the data that we're looking for similar to a picoscope? And then at the same time, if we can we use that same scan tool to do calibrations, initializations? And the reality is, in a lot of cases, that is true. So We have some things pulled up here. We've got everything kind of picked out, got it hooked up to the little monitoring station over here. So we're going to switch over so you can actually see what I'm doing on the scan tool, which is going to provide a lot of information to us, very similar to the Labscope, but we're also going to go through that initialization phase. So we're going to switch over to the Autel so you can see what we're doing and go step by step. And hopefully this will give you a little bit more insight into some things that are available to you through your scan tool. I've got a couple things set up here already, just so didn't make the audience watch the loading screen of the Autel here, but there is a lot of information we can get from the Autel if we don't have a Labscope available, but there's also a lot of functionality we can get out of the scan tool itself to get some of these recalibrations done or resets done on various different types of parts. But when it comes to these air door calibrations, this is one of the easiest ways to get it done, just going through the scan tool. So we've got it set up here. We're working with a 2025 RAV4. It's a hybrid. We've got it all loaded in. We've let it know that it is a North American vehicle made in Kentucky with a smart key. And so now we're going to go through the process of getting this recalibration done. And so what we'll choose is we want to get into a specific control module, right? Or a specific module. So we're going to go into control unit here so we can determine what we want to work with specifically. And of course, we're working with blend doors and air door actuators. So we're going to be working in the air conditioning system. And then from here, we'll go to our special function because there are certain things we can do. And then as you see here, there's a couple things we can do just in this special function on the air conditioning side or the tab of the scan tool. We can do a refrigerant high pressure history clear. We can do an air conditioner operation limitation history count clear, a refrigerant gas volume check, or what we're looking for here exactly, the servo motor initialization. So we'll go ahead and choose servo motor initialization. And here we go. This is what we need to know. This is what the manufacturer is saying is use this function when the servo motor or the air conditioning ECU is replaced or the battery is disconnected. So that's a big note there is in some cases, just disconnecting the battery will require you to go back in and do this special function to get those servo motors initialized and everything working properly. And this is again another really good thing to keep in mind, just that last little blurb there, which is if the battery is disconnected. There may be times when you're working on something completely unrelated where a battery has to be disconnected on a vehicle like this, where before you send the customer back out with the vehicle, we need to make sure we do this initialization, because if that information is lost, that customer's air conditioning system or the climate control within the cabin may not be what they expect, and they may end up having to come back and you'll end up still having to do it. So it's always good to check service information on things like what can be done or what can happen when a battery is disconnected, especially on some of these newer vehicles, the hybrids and the EVs. There could be a lot more, task that we need to complete before we can send that vehicle on. And so in this case, if we did have a servo motor replaced or an ECU or the battery disconnected, we would hit OK and we would go through that servo motor initialization phase. Now, we know we don't need to do that on this vehicle, so we're not going to do that, but we are going to hit escape here. We're going to get back into that control unit. And from here, I'm actually going to go to the live data tab. Now, yours may be different. If you may have the blocks on the screen or the options on the left-hand side like I have it set up here, but instead of special function, we're just going to switch over to live data. And again, from the live data area, there's a lot of things that we can see that, again, if we don't have a Labscope available to us, or we just need to verify something kind of quickly, we can use our scan tool. And what's really nice is, it'd be nice if every single data PID had a desired and an actual. We know that's not the case, but in this case, pretty nice. We do have a target pulse as well as an actual pulse when it comes to the driver's side air mix. So we'll choose those two, but we're also going to choose that for the passenger side. Let's look at both of those, because we can now graph these and actually watch them similar to what we could look at on a Labscope. And for this scenario, we're really just going to graph those four. So we'll do our graph. And as we can see in the moment, we do see that our driver's side target pulse and actual pulse are matching. We see that as well on the passenger side, but I want you to see those numbers because remember, Patrick was talking a minute ago about the counts that's going to be important too. If we know what the count should be based on service information, we can get some good information just based off of a quick graph here, watching those numbers. But one of the things I want you to look at here, and we saw it on a graph where we may not have an immediate response the way that we want. So I'm going to unsync the driver and passenger side AC on this vehicle. And we can watch how those lines won't be matching at first, but rather quickly they're going to match up the way they're supposed to once that door gets to the position it's supposed to be in. Now, once we see that, we can verify that the door is working properly. But again, this is also an opportunity to verify if the door is not working properly. So I'm going to increase the temperature on the passenger side here. And as we can see, it took just a couple of seconds, less than maybe 2, to get that done. And now we're matching. Same thing, if we take it back down, we'll see a real quick spike down, and then we'll have a matching line again. So by doing this, this is giving us the opportunity to verify whether the door is opening the way that we're asking it to open, and how quick it takes, or how long it takes for that to happen. Obviously, if we have a damaged air door or a slow or weak air door, it could take a much longer amount of time than we're expecting, and that's something we can go in and look at just based on this quick graph. And then let's imagine that we do decide to sync both sides. Right now, I have the driver's side set to low. We're in Texas, so obviously I want it low. But let's go ahead and take that back up to, let's say 72. And you see we had a pretty quick graph move there, but they lined back up. And now I'm going to hit sync on the passenger side button, and we're going to watch the passenger side do the exact same thing. And again, we know our doors are working properly because it's taking a very short amount of time and they're lining up exactly like they should. So whether I sync and take them both down at the same time, or I sync them up and take them both up at the same time, just a quick graph on a scan tool can let us know that these air doors are working properly. And when we request a different temperature, it's going to be able to blend that just right so that we get the temperature that we desire in the cabin. And so with that, Patrick, I'll send it back to you. But again, this is just a good quick demonstration to show, if we do, again, disconnect the battery or have an ECU change or a servo motor change, very quick, we can just jump in, hit a couple of buttons, get that initialization done, and we're taken care of. And the same thing is true if we're trying to diagnose a door that may not be blending right, opening right, closing right. We can jump into some live data, and without having to tear a whole bunch of probes out and wires out, we can kind of quickly see what these doors are doing and if they're matching up the way that the vehicle is expecting them to, and even more importantly, the driver is expecting them to based on the cabin comfort they're requesting. So Patrick, I'll send it back to you, and hopefully this is just a nice quick refresher for some folks around their scan tool when it comes to these air doors, these servo motors, any of the blend doors, or anything that goes into that dash when it comes to making sure that the AC is coming out of those vents the way we're asking it to. So there you go, Patrick.
Thanks, Corey, for setting up the scan tool and sharing that with us. Another quick tech tip, maybe just to jog your memory, is that many manufacturers rotate the fresh air recirc door to fresh air after shutting the vehicle off to ensure that the vehicle doesn't get strange odors and is able to air out while sitting. This is a good piece of diagnostic information to know when viewing scan data, or for if there's a click heard after turning the vehicle off. If this is the case, check the fresh air recirc door actuator first. As we wrap up this month's Power Hour on air door actuators and actuator recalibration, I just want to remind everybody that we have some great online resources with our Four Seasons YouTube channel that cover not only some of the items that we've discussed today, but a broad range of topics for DIYers, technicians in the shop, and everybody in between. So make sure to check out the channel at Four Seasons SMP and subscribe. And don't forget to go to 4s.com. That's 4S as in Sam, to look for those air door actuators that you're in need of. While you're there, check out the complete air door actuator kits that are available and they cover over 21 million vehicles on the road today. So with that, that's all I've got to say. If there's any other pending questions, Corey, I saw you over there looking at some questions, possibly. Is there anything that might be pending that we can answer from the group?
Yeah, you know what, Patrick, we actually do have a couple of good questions that are really related to some of the content you've already covered. But they're kind of a little bit different, and I think this would be a good way to give everybody the same answer rather than me answering it over here. So the first question is, the user wants to know, if I'm replacing a failed actuator on a vehicle, should I replace all of them at the same time or just the one? And I think you've got a couple of good input on that.
Yeah, no, that's an excellent question. So a couple of different answers. If the actuator is easily accessible in the case, then I'd say just go ahead and replace that one actuator that's failed. However, if you're going to have to rip the dash out of the car, the HVAC case is coming out as well. Just to get to that one actuator, I would say take advantage of all that labor that's been expended, the cost that's going to go into that, and replace all of those actuators, because they're not necessarily a high ticket item individually. So just take advantage of it so you don't have to go back to the shop and incur all those costs again, especially on those older model vehicles. I mean, they've probably already worn down anyways, so replace them all in one fell swoop. And also, we do offer the actuator kits, which is basically an all-inclusive actuator kit that has everything that you might need. So again, take advantage of those situations.
And I would agree with you, Patrick. Actually, that question came through a little while ago, and I held it. It came through when you had that picture of that F-250 pulled up with everything torn out of it. So I said, I'm going to hold this one for Patrick at the end. But and then just one more that I think is good to ask, just because you talked about this a little bit, but I'm sure there's going to be a lot of technicians that do run into this. How am I going to know the amount of pins that the actuator should have if someone has installed the wrong one previously? So if I'm, racking my brain trying to figure out why this one's not working, how can I verify it's the right pin out on there? And I think you talked about that a little bit, but just maybe something you can refresh on that.
Yeah, again, that's another good question. Definitely go to the primary source, the source material, the service information, wiring schematics or diagrams from the manufacturer. That's going to be your go-to source. So they will explain and show exactly the number of pins for whatever actuator that you're working on. And if there was some kind of an issue with the installation previously, then you can certainly go to those primary source documents and figure it out and make those corrections.
All right, very good, Patrick. Yeah, I'll leave it at that in the spirit of time here. So, I'll say thank you, Patrick, for leading us through this, and I'll let you close us out.
All right, thank you very much. For Corey and myself, we thank you all for joining us this month on this Power Hour, and look forward to seeing you all next month.